Welcome back to College Algebra, MAT 150. In this lecture, we will be discussing how to graph piecewise functions. So, piecewise functions, we've evaluated them now, but we don't know how to graph them. Well, it turns out graphing them basically is just sketching multiple graphs and just erasing what you don't need and making sure that it still satisfies what it means to be a function, which is passing the vertical line test. So, if we look at this, so let's just look at these separately. So we have 2x plus 4. So we're going to try to graph this line. Y equals 2x plus 4, f of x equals 2x plus 4. So we go up to 1, 2, 3, 4. 0, 4 is the y-intercept. And then we have a slope of 2, which is rise 2 and go right 1. Or do the opposite and go down 2 and left 1. And since we're kind of out of room here, let's do that. So down 2, left 1, and then we could get another point down 2, left 1 to get some pretty reasonable graph here. We get something like this. However, notice that that's not the only thing. We also have this little extra condition. So we graph this, and we only have values for when x is less than 0. Okay, so we have these outputs if x is less than 0. So x is 0 right here, right? So everything to this side goes away, but we keep everything to this side. So we can erase this. And further, at 0, we're saying, hey, let's stop using it. We can get really, really close to 0, but we don't use it. But if we plugged it in, it would basically get right up to 4. So if you plug in 0, 2 times 0 is 0, plus 4 is 4. So what we say in this case is for this less than, right at the point where we started erasing, we put a hole. All right? So this is the graph that we have. On this side, so this is this graph with this condition. Over here we have the opposite. So here we had stuff less than 0. Here we're only going to sketch the graph of stuff greater than or equal to 0. Again, if you see this ahead of time, you don't necessarily have to sketch then erase, but a lot of people find it easier just to try to deal with that as is. So negative 2x plus 2, so that means we have a y-intercept of negative 2x plus 2. So from this, we have 0, 2. And our slope is the number in front of the x, so negative 2, which we can think about as negative 2 over 1. So 0, 2 is this point. And we're going to go forward. So this says negative 2. So we go down 2 and right 1. Negative 2 and right 1. We can also go back to, or go up 2, go the opposite, and then left 1. That would give us something kind of like this. Not perfect, but it gives us an idea. But don't forget, we also have this condition. If x is greater than 0, so greater than or equal to 0, so basically from this point on the x-axis, this is the half that we keep. And we erase everything to the left. Further, because we can actually equal 0, we get a solid dot. And hence, this is what our graph looks like. So why did we go through this? Well, graphing a piecewise function, and notice we have a piecewise function down here. Piecewise function is 2x plus 4 if x is less than 0, and negative 2x plus 2 if x is greater than or equal to 0. So we have different formulas that we plug in depending on the x values. We have exactly this, which is what we just graphed. So we went up to 4, had this, and then had the hole. This is pretty small, but let me enlarge it here. And then here we have a solid filled in line, or dot, excuse me. And it's basically just taking these two that we have and putting them in to one graph. That's all we're doing here. All right, so this is the basic idea of what piecewise functions do. So you just graph each one of those individually, erase what you don't need, graph this individually, erase what you don't need, and remember that it should pass the vertical line test, the function that you have. So basically only one line. If you draw any vertical line anywhere, it should go through the graph at most once, if it does even go through it at all. All right, so let's do another one. So, but actually look at it in terms of points. And just as a reminder, so we're graphing each thing, each sort of piece of the piecewise function separately. Then we can just erase the extra. When we see the less than, the strict inequalities, like we saw here, where we start erasing, that's get the whole. And when we see an inclusive inequality, that gets a filled in dot. All right, so having said that, let's try another one, but we're actually looking at it as the piecewise function from the start. So h of x is negative x. So again, let's ignore the bottom one and just focus on this top one here. So negative x, so this means it has a y-intercept of 0, 0, has a slope of -1, which is -1 over 1. So we're kind of doing these separately. So 0, 0, and then -1 over 1 means it goes down 1, right 1, down 1, right 1. And we can go backwards, left 1, up 1, left 1, up 1 to get this line. And this is the graph that we have. Now, it says we should have this graph if x is less than 1. So let's find 1 on the x-axis. It's right here. And we want all numbers less than 1. So we want it like this. Okay, so we go up and down until we find the graph here. And what we're going to do is keep everything over here, but erase everything on the right of this sort of dividing line. And since this is a less than where we started erasing, that's just going to get a hole. Now, for the start of the second one, good idea to have an eraser for these. For the start of the second one, let's just ignore what we did for the first one. So we're just pretending we're looking at a blank graph. So we have basically, instead of y equals negative x, it's y equals x minus 3. So we have the y-intercept of 0, -3. And we have a slope of 1, which we can think about as 1 over 1. So -3, 0, -3 is here. And then we're going to go up 1, right 1, up 1, right 1, up 1, right 1. And we can go backwards, down 1, left 1, down 1, left 1. Scoop this up. Then we have something like this. Okay? Now, again, this is a function, so it should pass the vertical line test. Further, if we look at 1, so we want to use this graph for all values greater than 1. So again, 1 was right here. And since this is a greater than or equal to, so this for all values this way, we want to keep sort of this half of the graph, and we want to erase this half of just this line, not the other line. So we're pretending like the other line isn't there right now. So at 1, we have this, and we want to erase all of this here. Further, what we have left when we at this value, so this is all numbers greater than or equal to 1. So when we erase, what we have left behind is a solid dot. So this one was a hole, this one's a solid dot. These are not on the axes, so I'm actually going to label them just to be extra safe. 1, -2, and this is the point 1, -1. Oops. There's some remnant there. So 1, -1 is this point right here. Okay, and this is the graph. Again, it passes the vertical line test, has a hole, and the only place that looks like it might overlap is here, but it's a hole here, which means the vertical line would go through it, but intersect here. All right. We have one more example. And this one's a more complicated one in a certain sense, but an easier one in another sense. So here we have 3 sets of outputs. Oh, well, that's crazy. We've only seen 2 before. But thankfully, the outputs aren't crazy hard to divide. This represents, so on this interval, we have, when we try to plug in a number, our output is always -2. Our output is 4. For this one, this interval right here, our output is 4. And for this interval here, our output is -3. So remember, k of x is the same thing as y. So this is y equals a number for all of these. And what do these look like? Well, these are all horizontal lines. Okay? So in this case, this top one is just y equals -2. This middle one, it's y equals 4. And this bottom one, y equals -3. So let's do this one at a time. Y equals -2. So just go down 2, and it's just a horizontal line. But this horizontal line of y equals -2 only applies when x is less than -2. So let's find x being -2. So that's here. It's a strict inequality. So we basically use this output for everything here, but for everything else on this side we don't want because it's greater than or equal to -2. So we erase. And at -2, we have x less than -2. That's a strict inequality, so that means this part gets a hole. This next one, y equals 4. 1, 2, 3, 4. Just come up here, make a horizontal line at 4. But y equals 4 is an output only between -2 and 3. But we have a less than or equal to and a less than or equal to here. So between -2, which is here, and 3, which is here, this is what we want. Everything outside here we do not want. So erase here and erase here. And because this was less than or equal to both, we get solid dots here. Okay. Now, for the last one, y equals -3. So we just go down 2, down 1, down 2, down 3, make a horizontal line. Hopefully you can sort of see what's coming. Basically, where these graphs aren't, this is where this graph should be. So we have a graph here and here, up until about right here. Again, we have to pass, because it's a function, it better pass the vertical line test. And in fact, this is at 3, which is what this confirms to be. And it should always do it. There's no trick questions. I will always have this well defined. But we have all numbers strictly greater than 3. Again, that's a strict inequality. So this gets a hole. And this is what our graph looks like. You have this segment up here, and then this segment down here. That concludes this section.